Hello and welcome back to another video. In this problem, we're asked to solve each inequality for x, and we have some exponential and logarithmic functions here, and they're within inequalities. So in order to solve these inequalities, we're going to have to be converting exponentials to logarithms and vice versa. And since we're going to be moving things around from, let's say, the base of the logarithm over to the base of the exponent, and things are going to be switching sides, it might not be exactly clear, let's say for ln of x, which is log base e of x, is less than 0, which side is the x going to stay on, which side is the e going to stay on, and so on. The easiest way to think about it is the x has to stay on the same side of the inequality sign. So undoing this logarithm, we're going to have e to the 0 is equal to x, except it's not equal to x because this isn't an equation. It's less than x. However, the x has to stay on the same side of the inequality. So therefore, if ln of x is less than 0, then x has to be less than e to the 0. E to the 0 is 1, therefore 1 is greater than x. E to the x is greater than 5. Converting this into a logarithm means we have log base e of 5 is something to x. It's either greater than x or less than x. However, the x has to remain on the same side. So the x is on the greater than side on this one, so it has to be greater than log base e of 5, which is ln of 5. So these aren't that much more complicated than solving an equation. You just have to remember, keep the x on the same side of the inequality no matter where you move things around in converting from exponentials to logarithms and vice versa.